So the vision that Ken Moore really started developing almost 2 decades ago was one where we would have some type of a cover crop that we planted once, got those benefits year after year after year. And in that case, what you start doing is managing the competition between the annual crop, which is your moneymaker in general, and this ground cover, which, unlike annual cover cropping, the perennial ground covers aren't really there to try to make a secondary revenue stream. In my mind, they're there to provide ecosystem services at a low barrier to entry, that easy to do and low cost.
Welcome to the Crop Science Podcast Show by Wisenetics. I'm your host, Leo Bastos, Assistant Professor in Integrative Precision Agriculture at the University of Georgia. Today, for the first time, I welcome 2 guests to our show. The first one, Dr. Raj Raman and Dr. Dan Andersen. Raj is the Morrow Professor of Agricultural and Biosystems Engineering Department at Iowa State University and the Director of Regen PGC. Dan is an associate professor in manure management and water quality at Iowa State University and also involved in Regen PGC. Raj and Dan, welcome to the Crop Science Podcast Show. I'm really excited to have you here today and very excited about our conversation. And to get things started, I just want to ask you if each one of you could share with us perhaps the path that you took until you got to where you are today.
It's a pleasure to be with you today, Leo. And where do you start with these paths? I was an electrical engineering undergraduate student. I did that with a moderate lack of passion. I picked it on the advice of a person I respected a lot who loved me. And I did it, but it wasn't the greatest of fits. When I finished, it wasn't clear that that's what I wanted to do. And after flailing around for a little while, I found agricultural and biological engineering, and I pursued a PhD in that. I finished that degree effectively in 1993 and started as a faculty member at the University of Tennessee, which is a phenomenal place for me and a place where I spent the first 12 plus years of my career. I came to Iowa State in 2006 and have been a faculty member here since then. In terms of this project, the Regen PGC project, it is something that I came to very relatively late in my career. While my doctoral work had actually focused on instrumentation related to measuring nitrate uptake kinetics in very short time frames, I had moved through a variety of topics over the course of my career as a faculty member, and it was a little bit of a returning home, it felt like, to get involved in a project that in a very direct way had the potential to address some of the nutrient export issues that we struggle with in these very productive agricultural systems. In 2017, I started attending programming done by our friend and colleague, distinguished Professor Ken Moore, quite frankly, the progenitor of this Regen PGC vision. And through that, got involved with the project, ended up writing grants with Ken, pursuing a large project. And I think this is important to tell people, we tried repeatedly and got kicked in the teeth hard, and finally were funded in 2021. So this project, this Regen PGC project, which is a Sustainable Ag Systems coordinated agricultural project, started in 2021. And one of the things that I think bears saying is that all those experiences sort of getting beaten down by review panels and the like really strengthened the team. The team was working, the team was moving in other ways, and I think it's led to a very strong project. And I'll just end it there.
Nice, that's perfect.
Yeah, and I'm a farm kid. I grew up on a dairy farm in Wisconsin, a little small dairy farm. We only milk 30 cows. And similarly, I was told, get away from the farm. You have to find something else to do. And I thought, well, I like math, and I went to a small school, Wisconsin Platteville, and was a mechanical engineer.
Yeah.
And I went on a co-op, and it turned out I showed up in the dark and I left in the dark. And I was like, I can't live like this. I need to see sunlight. So started thinking about what are my other opportunities with what I've invested in my career, found agricultural engineering and thought, why do I want to design tractors? I want to be outside experiencing nature, doing things to help protect nature and be productive for agriculture. And that led me to the world of manure. And then more specifically, the way I got started on perennial ground covers is I did some work with cover crops up at a farm here in Iowa called Nashua. And Raj said, hey, let's do some perennial ground covers on this site too. And I thought, I don't know. But he said, it's going to be like driving on your lawn. It'll take care of compaction, make it more trafficable. And I said, all right, I'm all in. That's a problem we have with manure. Let's go.
Nice. Perfect. Well, thanks for sharing that. And I just want to comment, I do appreciate you sharing the hurdles that help to lead to success, right? We always normally see success, but we don't really know how many hurdles there were behind that. So I appreciate that comment. All right. So, we'll be talking about regen GPC, but we have not really defined it yet. So can you help me here to understand what is that? What does it mean? And more importantly, what is the vision behind that?
Sure. I think the underlying vision of these perennial ground cover systems is very similar to that. I could argue that it's synonymous with that of living mulches. The idea is that many, not all, but a multitude of the challenges that arise, the ecosystem service challenges that arise from modern monocropping systems occur because we don't have living cover on the soil for really the majority of the year. We know that annual cover cropping is a phenomenal thing to do. And I think it's important to say that we in Regen PGC, we don't wake up in the morning thinking we have to get all these people who are annual cover cropping to stop. I never feel that way. Annual cover cropping, for the people who can make it work and work well, they should just keep doing it. However, there are a lot of reasons I think that there is sort of a sort of soft ceiling on the amount of annual cover cropping that you're going to see in a region like the Upper Midwest. And one of the reasons is maybe combined reason is what I would call the tangible and intangible costs of doing it. There's tangible potential yield loss cost kind of thing. There are intangibles around when you have to do extra field operations, right? So the vision that Ken Moore really started developing almost 2 decades ago was one where we would have some type of a cover crop that we planted once, got those benefits year after year after year. And in that case, what you start doing is managing the competition between the annual crop, which is your moneymaker in general, and this ground cover, which, unlike annual cover cropping, the perennial ground covers aren't really there to try to make a secondary revenue stream. In my mind, they're there to provide ecosystem services at a low barrier to entry, that easy to do and low cost. I'll stop there and Dan can flesh out what I missed.
Yeah, but I think that's exactly what the vision is. We know cover cropping is great. We want living things on the soil all the time. And this is an alternative way to do that hopefully reduces labor during the critical time periods that Raj mentioned, right? Especially that fall season when we're really busy with harvest, busy with preparing for our next growing season. And we're out there asking people to do these things, establish cover crops when the Midwest often gets really dry and it isn't always advantageous to do that. And this is just a way to achieve some of the same goals with maybe a little less time investment when we're already a little too busy.
Awesome. This is fantastic. And I think, what I want to follow that up with is, perhaps most people are familiar with just cover cropping in general, where you do either kill or harvest that cover crop, right? So can you maybe just help us understand here, what would be some types of perennial coverage or crops that provide that perennial coverage, and how do you manage it? Like how, so Raj mentioned about the competition, that you then manage the competition of that cover crop with your cash crop. How does that work in practice?
Yeah, so there's a few examples of cover crops, perennial cover crop, living mulches that you could use. The ones that we're exploring the most are cool season grasses, particularly Kentucky bluegrass and Radix hybrid bulbosa. Both of them you have some familiarity with, right? They're lawn grasses, and in the South, Radix hybrid bulbosa is often used as a golf course grass to keep the golf course green in the winter. But it's really a Mediterranean grass, and that has some advantageous things for us. Both of those grasses, when it gets really hot and dry, tend to go dormant. So that means when you think about when corn is going to be most active in the Midwest, both of those grasses should be tending towards dormancy. Radix hybrid babosa to a much, much greater extent than Kentucky bluegrass, but both should be tending towards dormancy. And there's a slew of other things people could use. We often get questions about a legume. Can I use a clover of some type? Can I use alfalfa even, right? But those are much more challenging. And in the preliminary work that Ken Moore, the pioneer of this system, really did, he showed that some of these grasses probably are going to be a little easier to manage that competition. And that's where we chose to focus.
Yeah, and I think there's an important and perhaps uncomfortable point to talk about here. I think we're in an age where we want our solutions. We know that solutions that only address one thing are bad. I mean, in a way, that's how we got into the pickle we're in on some of our technologies, right? The problem, I think, is that when you look at the full opposite of that and say, I will only accept a solution that does all the things, I'm here to tell you those solutions don't exist. If they do exist, you'll find out they never cost out. And very idealistic solutions that don't get adopted on any measurable fraction of the landscape are never going to make the changes that we need. And I would say that that's a little bit of an epiphany that I've had. It only took me 20 of the last 30 years to get there. I learned slowly, but I really do think that we always, as we do this sort of agricultural technology development, need to be thinking about economics in the background, because if we want to make the impacts, we have to go to scale. So Ken and his student Scott Flynn, I think, tried 35 different ground covers and failed on about 34 of them. And as Dan explained, these ground covers that are complementary in space and time. So short, shallow rooted, but hopefully strong roots to hold soil, and early and late season active, summer dormant. And that sort of leads you to what Dan talked about. And I will tell you, as a non-agronomist, I mean, Dan's not an agronomist, but he's taken many more agronomy classes than me, and he's got a farming background. I think about technology development and this idea of technology readiness levels that you may be familiar with. And when we look at these perennial ground cover systems, we think we're somewhere around a TRL of 4 or thereabouts. NIFA actually has a technology readiness level for crops, for novelty crops, but we can use it here. And to get from 4 to 7, which is, I think, the game, it's usually, it's the valley of death. It's where you have to do it without having big company funds to do it. To do that, you can't do all the things. You have to pick some winners, and you know you're going to leave some things behind, but you have to do a good job with a couple of things so that you start to get adoption. And that's what we're trying to do.
And then I think the second part of your question was about how are we managing competition? How are we thinking about competition? And Raj hit on some of the important factors, right? Trying to control space and time so that it's not growing actively when the corn is. But there's a few lines of pursuit on that. The first one is really this was thought of and developed as a strip till system. So we want a crop growth zone. And I won't say strip tillage is the only way to maintain that, but we really do want to be cleaning up where our corn is growing. We don't want the grass there to be competing with water, to competing for nutrients, to scare the corn with the red light refractance. There's lots of things to balance there. So strip tillage is a friend to this system. Again, not necessary. You can probably clean up, and we do have collaborators trying to clean up the rows by spraying Roundup over that crop growth zone. But you need to make sure that's getting clean for the growing season. And then managing the grass color, essentially from when you plant corn to somewhere in that V6, V8 stage is critical.
Yeah.
Corn sees any competition, something growing in the field, as a weed, and it has a weed response to that limits yield potential. So we are doing what we call suppression, so trying to turn that ground cover brown and keep it brown from the moment that corn's emerged all the way through that time period. The start of the system was really thinking about hooded sprayers, managing those rows differently. We've evolved potentially to use Liberty or glufosinate to make the grass look like we killed it, make it look like it's pretty darn weak, hopefully keep it that way for the growing season. And then about the time you worry it's not going to come back, turn green in the fall, and make you happy that you still have that cover crop growing in your field. But you really do have to manage both. And when we talked about radix hybrid babosa, especially in comparison to Kentucky bluegrass, you can think there's lots of ways to do this. There's mechanical, there's chemical, but there's also biological. So focusing on the grass and when it would naturally grow dormant. We have a collaborator, Dr. Fay, who's trialing some new grasses, really turned us on to this radix hybrid babosa because it naturally will go dormant earlier in the spring. And that's a huge advantage to us. And we don't know that it's perfect, but they've been breeding it to try and be dormant. It's a much improved cultivar of that grass.
Yeah, it is very interesting to be in a project like this, and perhaps all agronomy projects are like this. I don't honestly know, but to me, this has a very, very large systems component to it. You are continually thinking about trade-offs when you think about these systems. And I'm not going to sugarcoat it. In some ways, this perennial ground cover vision is significantly more complicated than conventional agricultural production. I mean, there's a reason that we do things the way we do. It's more straightforward, right? It's easier to get rid of everything than it is to manage this competition, and in particular to manage it, in the case of Kentucky bluegrass, by knocking it back just enough that it's brown, not sending that shade avoidance response signal, but not so much that you have to replant it. I mean, that's tricky. I do think that's what's attractive about the RHB, the radix hybrid bulbosa, is that it stays dormant more readily, doesn't quite go dormant when we want unless you're planting really late. But anyway, it offers opportunities there. But the RHB is not quite as dense a mat of root. And so the level of certain ecosystem services may not quite be there. But trade-offs. That is something that our team talks about a lot and argues about. I think, I'm jumping way ahead. I think that good teams that are working on deployable solutions for ag need to be able to disagree internally, very frankly. I think that it's a critical quality in a strong integrated project.
I suppose the last thing we should mention there on the competition is you can work with the corn and soybean to find more resilient hybrids that maybe don't see the red fire red response as much as a weed. And that gets out of our area of expertise. But finding ways to work with biology rather than fighting it are critical. And that's an avenue we're exploring to some extent.
Yep.
That's fantastic. I mean, as everything in life and in ag, it's so complex, right? We have so many things at play that I totally agree that something that's going to work to the extent that we expect is probably not going to be a simple solution, right? So I want to follow up with one of those trade-offs and perhaps have a conversation about the biomass itself. So we know that, a given amount of biomass coming from that cover crop, regardless if it's annual or perennial, a minimum is required to provide certain services, right? So how does that, from your experience, how does that compare when we're talking about a perennial system or a perennial cover crop compared to an annual one?
Yeah, that's a great question. And some of this is going to be, we don't know. We're still working and exploring that issues. But one you might think of is weed control. And I think a lot of the work is showing you maybe need 2.5 tons to get weed control with an annual cover crop. And with some of our perennial cover crops, we just have less data. It's important to us to be getting that style of data. And our collaborators at Kentucky are helping us out and collecting exactly that. One I'm going to maybe narrow in on and focus on is more the environmental aspects, partly because that's where I do some stuff. And we have a direct head-to-head comparison. We've been growing cereal rye at the Nashua plots. We continue to grow them. And now we have some plots growing Kentucky bluegrass and radix hybrid babosa. So underneath those plots, we have a tile line. We intercept the water from that tile line, take a flow-weighted sample to know how much nitrogen are we losing, right? A critical question as we sit in the upper Mississippi Basin and think about what's flowing down to our neighbors in the south and impacting water quality there. And on those sites, we grow about on average 2 tons per acre of cereal rye cover crop, both before and corn or soybean, a little bit different in total mass, but relatively similar. When we look at what we've grown for perennial ground covers, it's substantially less for a couple of reasons. One, we're doing that strip till, so we only have it on essentially half the plot compared to when I cover crop, I have it on the whole plot. and bluegrass just doesn't grow as big as cereal rye. So we're growing more in the neighborhood of half a ton of biomass per acre, so substantially less.
Yeah.
And to your question, you might say, well, if you're growing 2 tons of cereal rye and only half a ton of this perennial, clearly you're not going to impact tile drainage to the same extent. However, what we have so far has shown that they've been pretty similar in how they've performed. And we could say several things about that, right? It might not be proportional to biomass. Maybe it's proportional to how much root they're growing. That perennial is just starting out ahead and giving us a better opportunity to capture some of that nitrate. The other place we've been doing some work on that is with erosion control. And again, we've seen relatively similar amounts. Certainly the amount of residue or the amount of root you have holding it together is important. On the other hand, we're talking growing any of these, Radix hybrid babosa, which is the sparsest, we still see an 85-90% reduction in the amount of erosion. And when you go to some of our cereal rye, okay, we can do a little bit better. We can get 95%. But there's years where it doesn't establish as well. And all of a sudden, when you start taking the variability of performance from year to year, they probably get pretty similar with that. So those are the ones we have the most data for.
Well, that's great. And again, I think it again just brings the point of trade-offs, right? You have strengths and weaknesses on both sides. It depends on how you want to balance them out. And in the end, how does all that complexity pay off?
Well, and I do think, and we've said it, but I'm just going to say it more directly. I think that in an annual cover cropping system, more biomass is better. It's almost a given. In a perennial ground cover system, the right amount of there is an optimum amount of biomass. And we've had trials that Shuizhang Fei, our colleague that we were referring to earlier, where he's run unsuppressed Kentucky bluegrass, and it gets, calf high anyway. And the corn yields suffer mightily with an unsuppressed Kentucky bluegrass at that kind of density. So to our way of thinking, and this is something we're working on. I think we can share this in your podcast. But we are thinking a lot about ways of making different perennial ground cover intensity ratings, because we're not really standardized on that in the literature, and we need to, because it's such a critical covariate that then it has implications for what yield will be, what ecosystem services will be, et cetera, right? So we are learning as we go forward about places that we can be more clear in how we describe these systems, because PGC acting like that's a monolith is a huge mistake.
And when you think about his intensity scoring, just for some clarity on that, it goes back to some of the things we said. How good are we doing for our crop growth zone? So how close is the grass to our row of corn, right? That distance is critical. So did we get it planted with precision where we want it to? Is it brown during those most active growing portions, right? So from the time that corn emerged to V8, how well did our suppression go? And then really the last one is just how much is there, right? Which goes to your question of does the amount matter?
Oh, this is really, really interesting. And so I think we already talked a little bit about some of the challenges, some of the benefits as well. So I guess my next question here for you on the technical side is, how scalable is this, and how do you think that where can this be an option for growers to adopt and see these benefits, and perhaps where you think this may not be the best option when comparing perennial with annual cover cropping?
Well, I think I might start with where it might not be the best option. And Raj pointed out that people who have already figured out how to work with annual cover crops, it's hard to learn something new, right? If you have a system that works for you, you're already doing that, keep doing that. And then just to expand on that a little, if you find yourself growing cereal rye for a forage for cattle production at all, keep doing that. Yeah. Don't be switching to perennial ground covers. You will be disappointed, right? There just isn't as much material there. But when you look around, especially the upper Midwest, there's a lot of people who are growing corn for grain for cash. There are a lot of people raising grain to feed their pigs. Those ruminants don't need that forage, and maybe we've seen less uptick of cover crops in some of those regions. I think if I was going to say who really should be thinking about it, if you find yourself in situations where growing degree days for cover crops get tight and you think, I'm just not getting enough biomass to make this pay for me, I think those are the places that I'd look first for. Is the perennial ground cover right for me? It's something that you don't have to worry about establishing in the fall. making sure you get good establishment because you've already done it. You have to get it right once, but after that, it hopefully works with you on that. So I think that's a key place to think about it.
Yeah, regarding scalability, one of the reasons I got involved in this project is that back in 2017, Ken Moore, again, our sort of progenitor of this whole thing, was running a series of lunch and learns for people across campus who were interested in hearing about this vision. And literally at the first one, I went because I was at a point in my career where I could see I sort of had to figure out what I was going to do the next decade. We had some large projects that I had very much enjoyed, but I could see that they were closing out and I needed to have a vision for what else to do. Ken was a friend, actually played in a band together. And I thought, okay, I'll go to this thing. So I went, and in that very first session, as he talked about this, what struck me was I started thinking, well, so this might actually cost out. Like maybe this is something that people could do. And I made a rough budget by hand and then did it in a spreadsheet and sent it to Ken. And I said, this is the way I think about this. Is this what you're thinking? He said, you should present this at the next meeting. And so that was 2017. And if people want to laugh at what kind of academic I am, it took 7 years. It was the summer of 2014 when Cindy Bartell led, she was the primary author on a paper that really took what I'd written down that day and did it properly in an enterprise budget format. We published it in Sustainability this summer. And what it shows essentially is that this can cost out. Now, it especially costs out if you happen to be in a place where people will pay you for your stover. There aren't that many of those places. But if you can make money on your stover, you can take more stover, we're quite confident, with this system. And that's an additional benefit, right? It makes it cost out very quickly. If not, and you assume maybe you save yourself one spray pass a year, maybe you can make it cost in 5 years or something like that. And that's before, I should say, these are in-pocket costs, not trying to economically value any of the ecosystem services. And they are real. But we wanted to do it in a very oversimplified way. So because of that, Leo, we do think that this can scale. The real problem, I believe, right now is twofold. It is the risk of a yield loss, which is, I don't know how to describe it. I think the risk is on the order of a 30%, not you lose 30%, but 30% of the time, given what we know right now, you're probably going to have a yield loss. And that seems too high for us to be out there really telling people to go big. But we feel like we've been pushing that down over the course of the last few years through the project. We're learning. We're failing. Dan and I failed at one this past year. But it makes us, failure, you learn a lot from failure. And we have had some really great successes. And I think that when we are managing that crop growth zone Dan talked about aggressively, and where we are getting that ground cover brown, we can achieve equal yield. And sometimes you get a little mulch effect maybe in the middle of the summer and get a little more moisture, and you're just, I don't want to say statistically significantly, but you might break even or do a little better. So we think it could be scalable. We have to deal with the yield issue, and we have to deal with the establishment issue. We learned that by starting a project in the middle of historical drought and having multiple years where we just really struggled to establish. And some of our farmer cooperators, farmers don't like to plant something that doesn't grow. So we're working on improving establishment, improving yield confidence, if you will. And then I think we start to go larger.
And we have had a fair number of trials where yields have been very similar. It's just some years we aren't so good at getting maybe suppression, or in my case, maybe I didn't manage my crop growth zone as good as I needed to. So I think those are things that you have to do some things wrong to say these are fundamentally the things as you play around with it in the real world that you have to do well. And the other things are in the margins that you can sort of say, this I'll adapt to fit my system.
Yeah, and I would imagine that, of course, growers are interested on yield. That's the metric they're looking at. But if you have a system that allows you to save fuel, or perhaps with pesticides, perhaps with water, I guess, and even these ecosystem services, for perhaps it is sequestering more carbon in the soil, and maybe the grower can get paid for that, right? So all these things that, I mean, if all of that is taken into account, it probably is a different picture than just looking at yield with and without, right?
Mm-hmm. Absolutely.
And I think one thing about scaling for this system, when you think about the number of acres I could maybe plant cereal rye cover crop in a given fall, there's some limit to what I can get to. And one of the advantages of scaling maybe a perennial is I can get to the same number of acres potentially to plant in the fall, but they'll still be next year. So when I go plant new acres of perennial ground cover, I've doubled my acreage, right? Or at least it's an additive effect rather than every year sort of having to start over and get the same numbers of acres hit.
Absolutely. Perfect.
It's time for our famous three. Rise and shine. A robust return on your sorghum investment is not just a dream. You can wake up with the peace of mind knowing you've wisely invested in Double Team Sorghum Cropping Solution, powered by the DT Trait Hybrid and First Act herbicide. They give growers over-the-top control of common grass weeds that reduce yield and profitability. Growers can get up to $137 more an acre compared to non-Double Team systems. Trust a system that gives you the performance you want. Learn more at doubleteamsorghum.com.
Well, we're getting towards the latter part of our episode. For those listening, if you're enjoying this conversation, please make sure you drop us a like, follow our podcast in different platforms, whichever one you may be listening, and also make sure to share with other people. This is a great conversation. I'm enjoying that so much, learning a lot, and I'm sure others can also benefit from all this great information. All right, so we're getting to the last three questions of our episode that we ask every guest. So I'm going to, perhaps I'll ask here and then you guys can decide if both of you want to answer or maybe just one of you. I'll leave that up to you. But the first question here is, if you have any resource that is ag related, so maybe, crops, soils, ag in general, but something that you came across and that you think is very useful, very helpful for you, and that you may want to share with others as well.
I'm going to take this one. I have an extension appointment, and the biggest resource is really just talking to farmers, right? So get out and talk to the growers in your area, and many are willing to share a lot about what they do and why. And it's great to get the diversity about what's happening there. I think if you want more of a written resource or something that anyone can find, ecology books and thoughts on how to feed the world, sort of this big picture ideas that really helps foster system thinking. One I read while I was a grad student was Vlakov Shmuel. And then I read a book called Holy SISH-T, right? And it was just a background perspective on manure and how to think about nutrient management and maybe recycling and thinking about systems. But I think getting that systems perspective is often helpful. And those were a couple that helped me think about it.
Raj, do you have anything that you'd like to add?
No, I think Dan's hit it. I was going to say, I read Freakonomics a long time ago. And I think that, as I said earlier, I think that as we do as we have these visions, thinking about what the economic implications are and what they might, how they might cost out, it's very important if we want to make differences on the landscape.
One that's funny that is sort of similar to me is I read sports blogs, and I think they came up with all these advanced metrics, and sports are data rich, right? Because they measure everything. And while ag systems look different, or any system looks different, seeing what people are doing to present their data, to think about how they look at a problem in there and say, do we do it because it was accepted knowledge, and what do the numbers behind that say, is really important.
That's interesting.
Yeah. So it was a weird application, but I liked reading about sports anyway, and I would read it and say, what does this tell me about how I should be thinking about ag differently? What's the conventional wisdom that I just accept that I should question?
Absolutely.
Well, that's interesting. Now that you said that, I'm very interested in aviation. I've always been interested in aviation and build gliders and et cetera, and model gliders. And I read a lot of aviation blogs and whatnot. And I think there's a lot of systems thinking that you learn hearing that, and risk analysis. And I find myself at times when we're thinking about this project, little weirdo things from that world are applicable here. So, yeah.
So read anything and think about how it relates to
you. Yeah.
That's right. No, those are really, really great resources and ideas, because definitely ag is very complex, just like a lot of other things in our lives, right? So we can definitely borrow some examples of how to think and how to present data from other fields. All right, so my next question is pretty much the same, but not in the ag technical aspect. So do you have any resources outside of ag that you would like to share with us?
Now we covered a lot of these.
We did.
Yeah. I really think systems thinking, right? You are not independent in what you're doing. So I recently read a book from, I can't remember the title. It was someone in the Navy, and it was about captaining the ship, right? So it was a leadership sort of, how do you direct your team and trust that your team's going to do well? And amazingly, I have a little trouble letting go of things, right? Like, yeah. So that was something that I had to work on. And he talks in that book about trying to do that. And while I still try and hold things close, because I'm like, I want to know the details of how it happens, I feel like that's been a growth area for me. We all want to know exactly what's happening, but sometimes you have to put good people in the right places and trust that they're going to do that. So I think for me, that leadership book was helpful.
Awesome.
Dan's problem is that he's smart enough to be able to understand all of that. I don't have that problem. So I like to work at 30,000 feet. And I do. I mean, this project, Regen PGC, works because we have an amazing team of 17 or so co-PDs. And then they're the people who work with them, staff, research scientists, graduate students, undergraduate students. They're making that go. And I think that's going to be a good segue to the next answer.
Next question. Yeah. That's right. So let's get right into that. So the last question here, as you already know, is what types of skills or skill set do you see on successful professionals around you?
So I'm a big believer that these kinds of integrated research projects in some way are a long conversation. Okay. And so some of those skills that serve us conversationally to actually be able to listen, to not just show up and do our PowerPoint and then be on our way, to really engage, listen and then engage, to argue and have disagreements in ways that allow you to keep working as a team, right? I mean, to do the things we want to do in ag, we're talking about half decade to decade long projects in general. And for a team to be functional for that amount of time requires that fundamental things like integrity, respect, and so on are really met by all members of the team. So it sounds pat, but I think those things are extraordinarily valuable and they can be cultivated. And especially those of us who are lucky enough to end up in leadership positions have huge opportunities to encourage or, frankly, break those kinds of qualities. And I think we need to encourage them.
Yeah, and I think I'll just say, foster your curiosity, right? There is so much we know about ag, but every day I show up and I say, there is so much more that I don't quite know, right? And because of that, I'm sometimes willing to ask a stupid question, right? I'm an ag engineer, not an agronomist. Right. And when the agronomists get into their technical terms, You say, what? I don't know. Can you help me out on understanding that? And I grow a lot from that. So foster that curiosity and don't be afraid to ask when you have a question.
Absolutely. It's really interesting that the more that we learn, the more we realize we know very little, right?
Yes.
And so, definitely that mindset is very, very helpful, especially, everywhere, I guess, in every profession, but especially as a researcher, right? That's what drives a lot of development as well. All right. So, this wraps up our episode. Raj and Dan, I really appreciated having you here today. I learned a lot from you and really appreciated the conversation around perennial groundcover and some of the benefits, the challenges of that. And really excited for our audience to also be listening to all these great thoughts and ideas. So thanks so much for being with us today. I really appreciate it.
Thanks for having us, Leo.